Here is the goal for today. We will start with an existing to-do in the simulator. We tap edit. The form opens up with all of its current values. We can change something, tap save, and we end up with this updated to-do. Simple from the user's perspective, but behind the scenes, we need to connect the screen, provider, and API to make that happen. So let's jump into code editor and build this journey step by step. Let's start by adding an onEdit parameter to the TodoItem constructor. We will also need a field to store this callback. Now our constructor receives both the TodoItem and the action that should execute when edit is pressed. Now we will simply connect this callback to edit buttons on press event. Whenever user taps edit, the TodoItem calls the function provided by its parent. The parent then decides what happens next. Next, let's open up TodoScreen.dart. We already have add or edit to do method for handling the add flow. So instead of creating a separate method just for editing, let's make this same method work for both add and edit. Currently, our add or edit to do method doesn't receive any information about the to do. So let's change that by adding an optional to do parameter. Why optional? Because when we tap the add button, there is no existing to do to pass. But when we tap edit, we will pass the selected to do. Now we simply forward that to do to AddEditTodoScreen. This gives AddEditTodoScreen access to the existing to do when we are editing. Next, we need to connect this method to onEdit callback we added earlier. So let's scroll down, go to the TodoItem. Here we already have the current to do. So when edit is pressed, we will call add or edit to do and pass this to do object. Hit save, and now let's test it. I will tap on the edit button of this to do, and the AddEditTodoScreen successfully opens up. Next, the screen opens successfully, but there is one problem. It still looks like we are adding a brand new to do. When we are editing, we want the screen to clearly say edit to do, and more importantly, show the existing to do details. So let's make the form aware of which mode it is in. Next, let's open up AddEditTodoScreen. We already received the to do as an optional parameter that gives us a simple way to determine the mode. So let's add a getter called isEditMode. If the to do is available, we are in edit mode. Otherwise, we are adding a brand new to do. Now we can use this getter to update the app bar title. So let's go to the app bar. If we are in edit mode, we will display edit to do. Otherwise, we will display add new to do. The title automatically changes depending on how the screen was opened. Next, we need to solve the bigger problem, prefilling the form. So let's go to the init state, and after initializing our controllers, first we will check if we are in edit mode. If we are, then we will populate the form using widget.todo. Hit save, and let's restart the application. Now if I tap on the edit button, the screen opens with the existing to do details already filled in. The title says edit to do and the form contains the values from the selected to do. That's exactly what we wanted. Before we move on, there is one important edge case we need to handle. What happens if the to-do already has a past due date or reminder date? We have two cases to consider. First, suppose the user only wants to change the title, description, category, or priority. We shouldn't force them to update the date just to save the changes. So we will allow the update and simply show the badges indicating that the due date and reminder date has already passed. Second, but if the user actually tried to change the past due date or reminder date, then we will make sure they select a valid future date before allowing the update. So our rule is very simple. Existing past dates show a warning but allow the update. Changing those dates require a valid date. This gives us a better editing experience without unnecessarily blocking the user. Now that we have decided how our edit flow should handle those past dates, we need a clean way to validate those dates. Instead of repeating the date-time comparison throughout our UI, let's keep this logic in one place. We already have our date-time extension with formatting helpers. Let's add 3 more helpers that we can reuse across the app. First is past date. This checks whether the date itself has already passed, ignoring the time. Next, we need to handle reminder dates, where the time is more important. For that purpose, we will add isPast datetime, which checks if the date and time is in the past. And finally, we will add isToday, which simply checks whether the date is today. Now that our date helpers are ready, let's use them to solve the edge case we discussed earlier. Keep existing past dates, but make sure any new date selected by the user is valid. During the add flow, our rules were straightforward. For the due date, we started the picker from tomorrow. And for the reminder, we allowed the user to select a date only up to the due date. Also, the reminder field stays disabled until a due date was selected. We want to keep all of that behavior, but now we also need to handle an existing to-do whose dates may already be in the past. First, let's update the due date function. For the due date, tomorrow it's still our first valid date. But in the edit mode, if the existing due date is still valid, we will use that as the initial date in the picker. If it is already in the past, we will start from tomorrow instead. So we preserve the existing value until the user actually decides to change it. Next, the reminder date follows a similar approach. First, we still require a due date before allowing a reminder. And if that due date has already passed, we ask the user to update it first. The reminder picker also keeps the due date as its last selectable date, just like in our add flow. But there is one new problem we need to solve. What time should the time picker open with? And that's where our getInitialTimeForReminder function comes in play. Inside this function, if the existing reminder date is still valid, we use its time. If the selected reminder date is today, we start few minutes ahead of the current time. And for any other date, we simply start with 9 am. This is important because a reminder for today can't use a time that's already passed. Finally, after user selects a date and time, we perform one last validation check to make sure the reminder is actually in the future. Before we move on to the actual save operation, there is one important UX improvement we should add. Right now, user can see the date, but there is no indication that it has already passed. So let's fix that. First, instead of building the warning UI twice, let's create a small reusable stateless widget called date warning. It simply receives a message and displays a warning icon with that message. Now we can reuse the same widget for both warnings. Next, right below the due date field, we will display the warning only if we are in edit mode and the selected due date has already passed. And we will do the same for reminder date, but using each pass date time because reminder includes time. Now there is a small UI problem. Currently, our column is adding space between every child. But now the warning is a separate widget between the date and the next field. That creates an extra space around the warning. So instead of relying on the column spacing, we will remove it and add an explicit size box after each form field. And now each warning appears right below its corresponding date field. The user can immediately see that the date has passed without being prevented from editing other to-do details. With this UI in place, we are ready to move on to the actual save operation. We already collect the updated title and description from the controllers. Now we need to create either a new to-do or an updated to-do depending on the current mode. So let's create a new variable called new or updated to-do. Here is what's happening. If we are in the edit mode, we use the existing to-do to create an updated copy with copyWith. And if we are adding a new to-do, then we continue using todo.create just like before. For now, I'm going to comment out the API call and print the object we just created. This lets us verify that our edit flow is actually producing the correct updated object before we connect it to the provider. Next, before connecting it to the API, we will test the edit flow and make sure the object contains exactly what we expect. For this to do, I will change the priority from high to medium. Hit save, and there is our updated to do. The priority value is correctly reflected in the object. So far, so good. Next, let's clear the debug console and try one more test case. This time, I will remove description, due date, reminder date, and tap save again. But that's not what we expected. Even though I removed the description, due date, and reminder date, the updated to-do still contains the original values. So let's debug this. Our application is now in debug mode. Right before calling copyWith, the description, due date, and reminder date values are null. So let's move forward. But after copyWith, the original values comes back. That means the problem is not with our form. The problem must be in the copyWith implementation. And that's exactly what we need to investigate next. So let's open up todo.dart and go to copyWith method. Here is our current implementation. We are using familiar null coalescing approach. The idea is very simple. If a new value is provided, use it. Otherwise, keep the existing value. But there is a small problem. For nullable fields like description, due date, and reminder date, we need to support two different meanings of null. First one, if the caller didn't provide a value, in that case, keep the existing value. And if caller explicitly provided a null, clear the existing value. With our current implementation, we can't distinguish between those two cases. If we provide a null values for nullable fields like description, due date, and reminder date, we will always fall back to the existing value. And that's exactly why we were not able to clear those values during an edit operation. To solve this, we will use callback function pattern for nullable fields. Now there are three possible states. If the callback is null, then don't change the existing value. If the callback exists and returns a value, then update the existing value. And if the callback exists and returns null, then explicitly clear the existing value. This gives copyWith the information it was missing. The difference between don't change this field and set this field to null. Next, it's time to test the scenario that originally exposed the bug. I have already updated the copyWith call in AddEditTodoScreen with a callback function for nullable fields. And description, due date, and reminder date fields are also cleared in the simulator. I will just hit save again. Perfect. Now the values for description, due date, and reminder date are correctly reflected in our object. Our updated to-do object is now working correctly. So the next step is to actually send it to the API. And since we already have an addTodo method in our to-do provider, we don't need to reinvent the wheel. We can use it as the starting point for editTodo. Next, let's open up todoprovider.dart, copy the addTodo implementation, and create our new method, editTodo. The saving state logic remains exactly the same. The first change is the service call. Instead of calling todoservice.addNewTodo, we will call todoservice.editTodo. But unlike add, we don't want to insert another to-do into the list. We need to replace the existing one. So we will call replace to-do. This helper method finds the to-do with the same ID and replaces it with the updated version. And with that, our editTodo method is ready. Now we need to connect it to the save button and make sure the correct provider method is called depending on whether we are adding or editing to-do. Let's go to AddEditTodoScreen, and instead of always calling addTodo, we will use a conditional expression. So in edit mode, the updated to-do goes to the editTodo method. Otherwise, the existing add flow continues to use addTodo. And regardless of which operation we perform, we get the same response. Now we can pass that response to handle response as we already do. Inside it, we will update the success message depending on the current mode. This way, the user gets the correct feedback without duplicating the response handling logic. We have now connected the entire edit flow, but before we call this feature complete, we need to test both sides of the story. What happens when the update succeeds and what happens when it fails? Let's start with the happy path. I will open up this to-do in edit mode. I will change the due date and reminder date and hit save. The request completed successfully. We get our success response, the screen closes, and the updated to-do is now reflected in the list. So the happy path is working correctly. Now that the success path is working, let's see what happens when things go wrong. To simulate an API failure, let's open up To-Do Service API IMPL. Inside Edit To-Do, let's throw a server exception. Hit save, and let's try to edit this to-do. I will remove the due date and hit save again. This time the request fails. Our error is displayed using snack bar and the screen stays open. This is exactly the behavior we want. And with both scenarios tested, we can confidently say that our edit flow is working end to end. While we are here, there is another to-do action sitting right in front of us, the checkbox. So let's implement the Toggle To-Do feature. The good news is that it's very similar to what we just did for edit. Just like we did with onEdit, let's add onToggle parameter to the TodoItem constructor. We also need a field to store this callback. Now let's connect it to the checkbox. The checkbox already gives us an onChange callback, so we simply call onToggle from there. We don't need the value here because the TodoItem doesn't need to know how the to-do should be updated. It just tells the parent, the user toggle this to-do. Next, let's go to To-Do provider and implement the actual toggle operation. But there is one important difference from edit. For a checkbox, we want the UI to respond immediately without waiting for the API. And that's where an optimistic update comes in play. First, let's create a new method called Toggle To Do. Unlike add and edit, we will just return a nullable string. Null means success, while a string contains the error message if something goes wrong. Next, let's perform the optimistic update. We create a new to-do with opposite completion state. Then immediately replace the existing to-do in our local list and call notify listeners. This means the checkbox updates instantly while the API request happens in the background. Next, we can reuse the same API handling structure from editTodo. And instead of calling the todo service.editTodo, we will call todo service.toggleTodo and pass the toggleTodo as a parameter. If everything succeeds, we return null because there is no error. But what if the API fails? This is where optimistic updates need a safety net. We roll back the local changes by putting the original to-do back and return the error message. So the flow is very simple. Toggle instantly, call the API, success, keep the change, failure, roll it back. And that gives us a fast UI without sacrificing consistency with the server. Next, we will connect our toggle to-do method with checkbox. Just like edit, we will handle this logic inside TodoScreen rather than putting provider logic inside TodoItem. Next, let's create a handle toggle method and import the snack bar helper. We pass the selected to-do to the provider and wait for the result. Remember, toggle to-do returns null when everything succeeds. But if something goes wrong, it returns the error message. So all we need to do here is show that error to the user. Next, let's connect our new method to onToggle callback. And just like that, the complete communication path is in place. The provider takes care of the optimistic update and API call, while TodoScreen handles the response. Now that everything is connected, let's put our toggle to-do feature through a quick real-world test. We will test both the success and failure scenarios. I will start by tapping this checkbox. And the to-do is marked as completed immediately. That's our optimistic update working. The UI doesn't wait for the API response. But let's verify that the change actually made it to the server. So let's go to Scalar, open up Get Todos endpoint and click Send. And here is our to-do. The each completed value is now updated on the server as well. So our success case is working end to end. Next, let's see what happens when the API fails. To simulate an API failure, let's open up Todo Service API IMPL. And inside editTodo, let's throw a server exception, as editTodo is called inside toggle todo. Now I will toggle the same todo again. The todo is toggled immediately. But once the API call fails, our provider rolls back the change to its original state and handle toggle displays the error message. And that's exactly why the optimistic update included a rollback. Our toggle to-do feature is working, but there is one visual detail we are missing. When a to-do is marked as completed, the UI should make that state immediately obvious. So let's update the to-do item to reflect that completed state. First, let's add a line through effect to title and description when the to-do is marked as completed. Next, we will change the title text color to on-surface variant when the to-do is marked as completed, so the completed content looks less prominent. Next, let's update the meta chips. For category, priority and reminder, we use on-surface variant instead of their normal colors whenever the to-do is completed. The due date needs a little more care because it has multiple states. A due date can be overdue, completed, or an active upcoming date. So instead of putting all those conditions directly inside the widget, we have created get color for due date to keep that logic in one place. Inside this method, if the to-do is overdue, we show the error color. If it is completed, we use on-surface variant. Otherwise, we use the primary color. Next, there is one more behavior we need to change. Once a to-do is completed, we don't want users editing it. So we will disable the edit action when to-do is completed. This keeps the UI and behavior consistent with the completed state. And with that, the edit and toggle to-do feature is officially complete. At this point, our users can add, edit, and complete to-dos. But there is still one important action missing: delete. In the next video, we will start working on the delete to-do feature and connect the delete action all the way from the UI to the API. Thank you for watching this video, and I will see you in the next one. Happy coding!